Hello, in this lesson, we will discuss analog signals, learn what an analog signal means, and in our next lesson we will work on a fun project. In the previous lesson, we worked with digital pins. Now we'll work with analog signals. Arduino digital pins are used to send digital signals to other devices such as LED, sensors, or actuators. They can be either in a high or low state, representing binary on or off signals. These pins can be used for digital inputs or outputs, and can also perform simple digital operations such as reading button presses, controlling LED. An analog signal is a continuously changing electrical signal. Think of turning up and down the volume on a radio. This change represents an analog signal. Analog signals can vary continuously, often carrying information related to the real world, such as music sounds or someone speaking. Arduino analog pins are input pins that can read analog signals and convert them into digital signals that can be read by the microcontroller. They are used to read analog values from sensors or other devices that provide continuous. Arduino boards have a limited number of analog pins, which can vary depending on the model. On the most popular Arduino board, the Arduino Uno, there are 6 analog pins. These pins are labeled with the letter A followed by a number, and they can be used to read analog signals such as those from sensors or potentiometers. These analog signals can then be processed and used to control devices or perform other functions in your project. To be processed by a microcontroller, analog signals are divided into parts, with each analog signal corresponding to a number. Due to Arduino's structure, it can measure a voltage range of 0 to 5 volt, and Arduino divides this analog value into 1023 parts, equating each analog signal to a number. Let's explain with a simple example. Within an Arduino with a measurement range of 0 to 5 volts, 5 volts corresponds to the number 1023. Using this ratio, for instance, a voltage of 3.25 volts corresponds to the value 665. When using analog signals in our programming processes, we must pay attention to this ratio and proportion. We will use a potentiometer with an adjustable resistor to obtain an analog value. The potentiometer adjusts the 5-volt voltage to different voltage values. We will make a moving light using the potentiometer. In our project, we will turn on the lights in sequence using different voltage ranges obtained from the potentiometer. I previously mentioned that the analog value from the potentiometer is converted into a digital value between 0 to 1023. Now, we will divide the values received from the potentiometer into certain ranges and sequentially feed them to the pins that control the LED. As we turn the potentiometer, the corresponding pin in the relevant range will become active. Here we will use a new feature called creating variables. Let me briefly explain what a variable is. Variables are areas where a value is stored in programming. We will create a LED value variable in the project and store the analog value inside it. You can create a new variable by following the steps below. First, we click on the variable section. Then we click on the Make a Variable button. We write the name of our variable and click the OK button. We have now created our variable. Before continuing with the program, let's set up our circuit. We place our LED sequentially on the board as shown in the image. As always, we connect the positive legs of our LED with resistors to the Arduino's pins 2, 3, 4, 5, and 6. We connect one leg of the potentiometer to GND and the other leg to the Arduino's 5-volt pin. We connect the middle leg of the potentiometer to the Arduino's analog pin 0, and our circuit is ready. Now we can start coding. First, we need to define the analog pin we will use. In this project, we will use the A0 pin. Arduino will convert the analog information from this pin into a digital value. By dividing the converted digital values into specific ranges, we will decide which digital pin to activate. To ensure equal distribution, I divided it into 200 unit parts. After selecting the required analog pin, I will choose which digital pin will be activated by the digital value between 0 to 200. To keep it sequential, I will activate the digital 2 pin to which my first LED is connected and deactivate the other digital pins. Now, I will divide it into 200 unit parts sequentially and activate the other digital pins in order. I am selecting the last pin between 800 and 1024 because if I choose between 800 and 1000, Arduino will not output anything for the range 1000 to 1024 since no selection has been made for that range. Here is the complete program. Now let's see what this actually looks like. As you can see, I'm moving the LED lights by turning the potentiometer. Thank you for watching. See you in the next lesson.